Hey guys, welcome to my course in statistics. In this video, we're going to talk about some of the basic terms used in statistics, and we're going to start with the most popular concept in stats, and that is data. Now, what is data? Well, in this course, we're going to assume that data is basically the same thing as a table. So when I say data, think about a table. To be more exact, it's a table that shows some kind of information. Now, I'll give you an example to explain what I mean here. Let's say I'm a statistics teacher and I got 50 students in my class, okay? And one day I decide to create a table that shows all the possible information about my students. It shows their names, their addresses, phone numbers, email addresses, GPAs, SAT scores, and so on. But this table that shows information about my students is called data. I'll give you one more example. Let's say I'm a manager at some kind of a huge organization and I got like 1,000 employees working for me, okay? And one day I decide to create a table that shows all the possible information about my employees. It shows their names, addresses, phone numbers, salaries, education levels, and so on. Okay, this table that shows information about my employees is basically called data. Here's one more example, guys. Let's imagine that I'm a businessman, okay? And I got 10 employees working for me. One day I create a table that shows the names of my employees, shows their genders, ages, education levels, salaries, and so on. This table that shows information about my employees is basically called data. So I hope you guys understand what I mean by the word data. So when I say data, please think about a table like this that shows information, it just shows some kind of information, okay? Now guys, the next term that I want to explain today is called a variable. Now to explain what I mean by the word variable, I want to go back to this table that shows information about my employees, okay? Now please write this down. In any kind of data, the first row shows variables. Okay, so this data set over here, this table has 8 variables. Now gender is a variable. And this variable has 2 possible values, male and female. Education level is a variable as well, and as you can see here, it has 3 possible values, bachelor's, master's, and PhD. I'll give you one more example. The number of kids is a variable. As I can see here, it has 4 possible values. I'm going to start with the lowest value, 0. The next lowest value is 1, 2, and the highest value is 3. I'm going to write this down here. So the number of kids is a variable that has 4 possible values in this context. 0, 1, 2, and 3. And age is a variable as well. Now, how many values does this variable have? Let's start with the lowest value. Now, as I can see here, the lowest value is 20. The next one is 21, 25, 28, and the highest value is 30. So as I can see here, in this data, the variable age has 5 possible values. 20, 21, 25, 28, and 30. Now, the variable place of birth has 3 possible values, Dayton, Akron, and Chicago. Now, the variable ethnic origin, as I can see here, has 4 possible values, English, French, German, and Spanish. Now, please remember, again, let me say it again. In any kind of data, the first row shows variables. Okay, now what's a variable? Well, basically a variable is something that varies, okay? It's something that changes, something that is not constant. For example, age is a variable. Why? Because it varies depending on people. It changes depending on people. It varies across different people because someone is 30 years old, someone else is 25 years old, and this guy whose name is Tom is 28 years old. So age varies, across different people. It changes depending on people. So that's why age is not something constant, it's a variable. If all the people in my sample, if all the people here in my table had the same age, then the variable age wouldn't be a variable, it would be something constant. And gender is a variable as well because it varies across different people. Some people are males and some of them are females. Same can be said about the number of kids or ethnic origin or the place of birth of salaries, because the salaries, all people have different salaries. They change. I mean, the salary changes, varies across different people. It changes depending on people. That's why salary is a variable. It's not something constant, right? Now, I hope you guys know what a variable is. Now, please write this down. Any kind of a variable is either quantitative or qualitative. Now, qualitative variables are sometimes called categorical variables. Now, I want to explain the difference between them. Now, if some kind of a variable takes on numeric values only, then this variable is quantitative. Now, if some kind of a variable doesn't take on numeric values, then this kind of a variable is qualitative, or sometimes called categorical. Now, what I'm trying to say here is that if all the values of a certain variable are numbers, then this variable is quantitative. Now, if all the values of a certain variable are not numbers, but just words, then this variable is qualitative or categorical. Here's an example. Age is a quantitative variable. Why? Because all the values of this variable are numbers, right? Same can be said about the variables like salary, height, and the number of kids. These variables are quantitative. Why? Because the values, all the values of this variables are numbers, okay? But if all the values of a certain variable are not numbers, just words, then this variable is qualitative or categorical. Here's an example. Gender is a qualitative variable. Again, why? Because as you can see, all the values of this variable are not numbers, they just words. Same can be said about the variables education level, place of birth, and the variable ethnic origin. These variables are categorical, again, because the values, all the values of these variables are not numbers, they just words. I hope you guys understand the difference between a quantitative and a categorical variable. There's one more thing that I want to talk about today. Please write this down. Any kind of a quantitative variable is either discrete or continuous, okay? Now, if all the values of a certain quantitative variable are whole numbers, integers, then this kind of a variable is discrete. If some of the values are whole numbers and some of them are fractions, then this kind of a variable is continuous. Here's an example. Age is a discrete variable. Why? Because all the values of this variable are whole numbers, integers. That's why this variable is discrete. Same can be said about the variable number of kids. As you can see here, the values of this variable are whole numbers, so this variable is discrete. But the variable height is actually not discrete, it's continuous. Why? Because some of the values of this variable are whole numbers, but some of them are fractions, like 175.2 is not a whole number, it's a fraction. Same for 167.4 and 173.2. Right? And now the variable salary is continuous as well, because again, some of the values are whole numbers and some of them are fractions, like 2740.7 is not an integer, it's not a whole numbers. That's why the variable salary is continuous. Actually, the difference between the discrete and continuous variables is more complicated than this, but since we just started learning statistics, I want you guys to keep it simple. Just think of it this way: if all the values of a variable are whole numbers, then the variable is discrete. But if some values are whole numbers and some of them are fractions, then this variable is continuous. Okay. Okay guys, now that you know the types of variables, I want to explain how to build a graph. Okay, now what is a graph? Well, basically a graph is something that shows a variable. So any kind of a graph usually shows one variable. I'll give you an example, okay? Let's choose the variable education level here from this table and build a graph for it, okay? Now, please tell me, how many values does this variable have? Well, as you can see here in this table, the variable education level has 3 possible values: bachelor's, master's, and PhD. Okay. Now, how many employees, how many people here in this table have a bachelor's degree? Well, as I can see here, 6 of the employees have a bachelor's degree. So I'm going to write 6 over here. Now, how many of the employees have a master's? Bob and Sarah have a master's degree, so I'm going to write 2. So 2 of the employees, 2 people have a master's degree. Now, how many people have a PhD? John and Hannah. So 2 people, 2 employees have a PhD. All right. Now, the numbers that you see here are called frequencies. Okay. Please write this down. Now, what's a frequency? Basically, a frequency is the number of people that belong to a certain value of a certain variable. For example, the frequency of the value bachelor's is 6. That means 6 employees have a bachelor's degree. The frequency of the value master's is 2. That means 2 people, 2 employees have a master's degree. Now the frequency of the value PhD is 2. That means 2 people have a PhD degree. Okay. Now, why do you have to know what a frequency is? Well, in order to build a graph for a certain variable, you have to know the values of this variable and the frequencies for those values, okay? So let's build a graph that shows the variable education level. That's very easy, guys. Just build 2 axes like this. Then write the name of the variable below the axis, okay? The name of the variable is education level. Okay, now show the values of this variable on the x-axis. Now the values of this variable are bachelor's, master's, and PhD. Bachelor's, master's, and PhD. Now the y-axis is going to show the frequencies for those values. Okay, for example, the frequency of the value bachelor's is 6, so I'm going to build a column like this, ending at 6 here. Now the value master's has a frequency of 2. That means I'm going to have to build a column for the value master's, and this column is going to end at 2. Right? And now the frequency of the value PhD is 2. So I'm building a column ending at 2. All right. Now here is a graph showing the variable education level. The x-axis of this graph is showing the values of this variable, and the y-axis is showing the frequencies for those values. Now, just by looking at this graph, I can see that 6 people at this company have a bachelor's degree, 2 people have a master's, and 2 of the employees have a PhD. Okay, this kind of a graph is called a bar chart. Now, what is a bar chart? A bar chart is a graph that shows a categorical variable. Okay, we know that the variable education level is categorical. Yeah? So please remember that a graph that displays a categorical variable is called a bar chart. And in any kind of a bar chart, the x-axis shows the values of the variable and the y-axis shows the frequencies for those values. I'll give you one more example, guys. Let's build a bar chart for the variable gender. So again, I'm going to have to build 2 axes like this. Then I'm going to write the name of the variable, which is gender. Now, the values of this variable are male and female. And the y-axis is going to show the frequencies. Now, the frequencies for the values are 6 and 4. How do I know that? Well, the value male has a frequency of 6 because 6 of the 10 employees are males. So I'm building a column here ending at 6. Now what's the frequency for the value female? Well, I see 4 females here. So the frequency of the value female is 4. No? Well, that's it. Well, this graph is called a bar chart. Why? Because it's showing me a categorical variable, which is gender. And I can see here in this graph that 6 of the employees are males and 4 of the employees are females. Okay, let's choose one more variable and build a graph for it. Let's go with the variable number of kids. Okay, now again, I'm going to build 2 axes like this. I'm going to write the name of the variable here below the x-axis. So I'm going to label the axis as the number of kids. Now, I'm going to list the values, all the values of this variable here on the x-axis. So I'm going to start with the lowest value, okay? The lowest value is 0. The next lowest value is 1. The next one is 2. And the highest value for this variable is 3. The y-axis is going to show for the frequencies for the values. I know that the frequency of this value is 5. The frequency of the next value is 1. It's actually 2, because I see 2 employees here who have 1 kid. So the frequency of this value is 2. Now, how many employees have 2 kids? 1, 2. Now, how many of the employees have 3 kids? Only 1. His name is John. Okay, here's the graph showing the variable number of kids. I can see from this graph that 5 employees have 0 kids, 2 employees have 1 kid, 2 of the employees have 2 kids, and only 1 employee has 3 kids, okay? This kind of a graph is called a histogram. Now, what's a histogram? A histogram is basically a graph that shows a quantitative variable, okay? Please remember that a graph that shows a categorical variable is called a bar chart, whereas a graph that shows a quantitative variable is called a histogram. That's the basic difference between a histogram and a bar chart. Now, compare this histogram to the bar chart over here. How are they different from each other? Now, the basic difference is that in the bar chart, there is a gap, there is basically a space left between the columns, whereas in a histogram, there is no space between the columns. All the columns border on each other, okay? The second difference between a bar chart and a histogram is that in a bar chart, there is no order in the values. I mean, the order of the values doesn't matter. You can first put the value male and then put the value female, or if you want, you can put the value female first and then write the value male. So the order of the values doesn't actually matter in any kind of a bar chart. But in a histogram, there has to be a strict ascending order. You have to start with the lowest value and then finish with the highest value. I mean, there has to be an ascending order in any kind of a histogram. I hope you guys enjoyed this video lesson about the basic terms used in statistics. If you like this video, please sign up for my channel, and see you guys in my next video lesson. Hey guys, in this video I'm going to explain what a relative frequency is, okay? For that I'm going to use a small example. Let's say I'm a manager at some kind of a small organization. I got 10 employees working for me. And this table, this data set is showing some information about my employees. It's showing me the genders, ages, education levels, salaries, and places of birth of my employees. Now, let's imagine that I built a bar chart that shows the genders of my employees. I can see in this bar chart that 6 of the employees are males and 4 of the employees are females. Now, we know that this bar chart is showing the variable gender. The x-axis is showing the values of this variable, and the y-axis is showing me the frequencies for those values. Now, if I divide the frequencies by the total number of people in my data set, then I will convert the frequencies into relative frequencies. So the total number of people is 10. So 6 divided by 10 is 0.6, and 4 divided by 10 is 0.4. Now, what is a relative frequency? Basically, a relative frequency is the same thing as a proportion. Okay, now what's a proportion? A proportion is almost the same thing as a percentage. Now, what's the difference between a relative frequency and percentage? We know that percentage is usually measured on a scale from 0 to 100, like 50%, 60%, or 70%. Now, whereas relative frequency is measured on a scale from 0 to 1, like 0.4, 0.5. That's the only difference between them. I'll give you an example. I can see in this bar chart that the frequency of the value male is 6. That means that 6 of my employees are males. And the frequency of the value female is 4. In this context, it means that 4 of the employees are females. Now, in this bar chart, the y-axis is showing relative frequencies instead of frequencies. So I can see in this bar chart that the relative frequency of the value male is 0.6. That means 60% of the employees are males. Now I can see that the relative frequency of the value female is 0.4. In this context, it means that 40% of all the employees are females. Okay, that's how you can interpret the relative frequency in this context. One more example. Let's say that this histogram here is showing me the variable age. Okay, now the y-axis here is showing frequencies. For example, the frequency of the value 20 is 2. That means 2 of my employees are 20 years old. Now the frequency of the value 25 is 1. That means 1 employee is 25 years old. Now, this histogram over here is also showing the variable age, but the y-axis here is showing relative frequencies, not just frequencies, right? So for instance, the relative frequency of the value 20 is 0.2. That means, in this context, it means 20% of the employees are 20 years old. Now the relative frequency of the value 25 is 0.1. That means 10% of the employees are 25 years old. So that's the basic difference between a frequency and a relative frequency. Usually a frequency shows the quantity, right? Whereas the relative frequency shows the proportion. And we usually interpret the proportion in percentage. Now, please write this down. If I say, construct a bar chart that shows the frequency distribution of the variable gender, then build a bar chart like this and make sure that the y-axis shows frequencies, okay? But if I say construct a bar chart that shows the relative frequency distribution of some kind of a variable, then build a bar chart like this and make sure that the y-axis shows relative frequencies, not frequencies. Please remember that. Now if I say build a histogram that shows the frequency distribution of some kind of a variable, then build a histogram like this and make sure that the y-axis shows frequencies, not relative frequencies. But if I say build a histogram that shows the relative frequency distribution of some kind of a variable, then build a histogram like this one and make sure that the y-axis shows relative frequencies, not frequencies. Again, if I say build a bar chart or a histogram that shows the frequency distribution of some kind of a variable, then make sure the y-axis shows frequencies. But if I say build a bar chart or a histogram that shows the relative frequency distribution of some kind of a variable, then make sure that the y-axis shows relative frequencies, not just frequencies. Okay? Guys, in this video I'm going to show you how to build a histogram for a continuous variable. Okay, please look at the histogram over here. It's showing me the variable number of kids. Now, this histogram has 4 columns. Why? Because the variable number of kids has only 4 values, 0, 1, 2, and 3. Now, if you build a histogram for the variable age, then your histogram is going to have 5 columns. Why? Because the variable age has 5 different values, 20, 21, 25, 29, and 30. But if you build a histogram for the variable salary, then your histogram is going to have 10 columns. Why? Because the variable salary has 10 different values, and none of the values are repeated. So if you construct basically a histogram for the variable salary, your histogram is going to have 10 columns, and the height of each column is going to be equal to 1. This kind of a histogram is not convenient, and I would say meaningless. That's why when building a histogram for a continuous variable like a salary, for example, we'd better use intervals. Why? Because continuous variables usually have too many values. So let me show you how to build a histogram for a continuous variable. So we're going to build one for the variable salary here. Now, so I'm going to build 2 axes. I'm going to write the name of the variable here. The y-axis is going to show frequencies. Now, please tell me how many employees have a salary between 1,000 and 2,000. Well, as I can see here, only one employee, her name is Kim, has a salary between 1,000 and 2,000. She has a salary of $1,320.50. So I'm building a column like this that has a height of 1. So the frequency of the first column is equal to 1. Now, how many employees earn between 2,000 and 3,000? 5 employees. I'm talking about Alice, Tom, Joseph, Juan, and Sam. So I'm building a column with a frequency of 5. Now count the number of employees who earn between $3,000 and $4,000. Okay, it's Hannah, Sarah, and Bob. So the frequency of the next column is equal to 3. Now please note that Hannah has a salary of $3,000 and she's right on the boundary over here between two columns. Now please remember, if some person is right on the boundary between two intervals, then this person belongs to the next interval. So Hannah is basically right here on the boundary between two columns. That means she belongs to the next column. She belongs to the column to the right from 3,000, okay? She's here, not here. Now, how many employees earn between $4,000 and $5,000? Okay, there's no one who has a salary between $4,000 and $5,000. Now, and there's one person with a salary between $5,000 and $6,000. His name is John. So here's the histogram showing the variable salary. I can see in the histogram that one person has a salary between $1,000 and $2,000. 5 people have a salary between $2,000 and $3,000. 3 employees earn between $3,000 and $4,000, and only 1 employee has a salary between $5,000 and $6,000. Now compare this histogram to the previous one. How are they different? Now this histogram is showing the variable number of kids. We know that this variable is discrete. And most of the time, discrete variables usually have very few values. And that's why when building a histogram for a discrete variable, we usually build a separate column for each value. Now, the variable salary is continuous. And most of the time, continuous variables have continuous variables usually have a huge number of values. They usually have lots of values. And so building a separate column for each value is meaningless, so we use intervals. So when building a histogram for a continuous variable, we don't build a separate column for each value. We build a separate column for each interval. So please remember, when building a histogram for a discrete variable, build a separate column for each value of that variable. Now, when building a histogram for a continuous variable, don't build a separate column for each value of the variable. Just group those values, use intervals and build a separate column for each interval. Why? Because continuous variables usually have too many values, and you shouldn't build a separate column for each value. That kind of a histogram is not going to look beautiful. Now, as you can see, the size of each interval here, the width of each interval is equal to 1,000, right? You can actually change the size of the interval. You can change the width of the interval, but in that case, your histogram is going to have a different shape. Here's an example. This histogram is showing the same variable, but it has a different look. Why? Because the width of each interval here is equal to 500. That's why this histogram has more columns and more gaps. So you can choose, the width of an interval at your own discretion. Just keep in mind that your histogram is going to have a different shape if you change the size of the interval. Hey guys, in this course we're covering 3 types of graphs: bar charts, histograms, and dot plots. Now we know that a bar chart is a graph that shows a qualitative variable, whereas a histogram is a graph that shows a quantitative variable. Now, a dot plot is a graph that can show both qualitative and quantitative variables. Now, you guys already know how to build a bar chart and a histogram. Today, I want to show you how to build a dot plot. For that, we're going to choose one variable from this data set and build a dot plot for it. Let's choose the variable education level. So I'm building an axis like this. Okay, I'm going to write the name of the variable below the axis. It's education level. Now we know that this variable has 3 values: bachelor's, master's, and PhD. So I'm going to write the names, the values. I'm going to show the values of this variable here on the axis. And we know that 6 people have a bachelor's degree here. So I'm going to write, I'm going to draw 6 dots above the value bachelor's. And 2 of the employees have a master's. And let's count the number of people who have a PhD. It's 2. So that's it. It's very easy. It's a dot plot showing the variable education level. And I can see from this dot plot that 6 people have a bachelor's, 2 people have a master's, and 2 people have a PhD. Now, this dot plot, this graph is showing a qualitative variable. Let's build a dot plot for a quantitative variable. We're going to choose the easiest variable, the number of kids. and build a dot plot for it. Now, this variable has 4 possible values. Okay, now the value 5, the value 0 has a frequency of 5, because 5 people have 0 kids. So I'm going to draw 5 dots above the value 0. Now, how many people have 1 kid? 3 people. 3 employees have 1 kid, so I'm going to draw 3 dots above the value 1. Now let's count how many people have 2 kids. Only 1 person has 2 kids, and only 1 person has 3 kids. Well, that's it. Here's a dot plot showing the variable number of kids. We know that it's a quantitative variable. Now, I can see in this graph that 5 employees have 0 kids, 3 employees have 1 kid, 1 employee has 2 kids, and this guy, 1 person has 3 kids. Hey guys, in this video I want to talk about the difference between the mean and the median. I think you guys know what a mean is. It's basically the same thing as the average. Now, to calculate the mean, you just have to sum up the values of all the subjects and then divide that sum by the total number of subjects. I'll give you an example. Let's say I got 5 students in my class and they all had an exam on statistics, and one of the students scored 50 out of 100, the second student scored 55, the next one scored 60 out of 100, and all the rest of the students scored 70 out of 100. Now, if I want to calculate the mean, let's say I want to calculate the average score for this group. Well, in that case, I just have to sum up the scores of all the 5 students and then divide that sum by the total number of students, which is 5. That's going to be equal to 61. So the mean in this context is equal to 61. That means the average score in this group of 5 students is equal to 61. Now here's the formula for the mean. This formula is showing me that x bar is equal to sigma x divided by n, where x bar is a symbol for a mean, which is the average. Sigma is a sign for the sum. N is a total number of subjects, whereas x is the value of a certain subject. Basically, this formula is telling me that if you want to calculate the mean, you just have to sum up the values of all the people and then divide that sum by the total number of people. Okay, I'll give you an example here. Let's say if I ask you guys to calculate the mean for the variable age, you just have to sum up the ages of all the 10 people here and then divide that sum by the total number of people, which is 10. Same for the variable height. If I say calculate the mean for the variable height, just sum up the heights of all the 10 people here and then divide the sum by 10, which is the total number of people. Okay. Now, I hope you guys remember what a median is. Basically, a median is a number in the middle, in the center. To calculate the median, we just have to put all the values in ascending order first. I'll give you an example again. Let's say I got 7 students in my class, and here's the exam scores of my students. Okay. Now, I want to calculate the median score. Well, in this case, I just have to put all these values, I have to put the values of all the subjects here in ascending order. I have to put the exam scores of all the 7 students in ascending order. I have to start with the lowest value, the lowest score, and finish with the highest score. So the lowest score over here is 50. The next lowest score is 55. The next one is 62, 65. The next one is 70, 78, and the highest score is 81. So as you can see, I put the scores of all the 7 students in ascending orders, starting with the lowest value and finishing with the highest value here. So now I have to find the number right in the middle. The number right in the center here is 65, okay, right in the middle. So this is the median. Now what if I had 8 students in my class, not 7? Well, let's see. Now in order to find the median, I just have to put all the exam scores in ascending order again. So the lowest score is 50, the next one is 55, 62, 65. Hold on one second. I made a mistake over here. I got 2 students who scored 55, so I'm going to write 55 twice here.
Okay. So the lowest score is 50, the next one is 55, 55. The next one is 62, 65, 70, 78, and 81 is the highest score. So I got 8 students in my class, and I put the exam scores of all the 8 students in ascending order. Now I have to find the 2 numbers right in the middle. Okay, and then calculate the average for these 2 numbers here. So the average for these 2 numbers is 62 plus 65 divided by 2, which is 63.5. So the median for this group of 8 students is equal to 63.5. So please remember that if you have an odd number of people in your group, then the median is the number right in the center. Now, if you have an even number of people, then the median is the average for the 2 numbers right in the center. Okay? Hey guys, let's say I got 75 students in my class, and I divided my students into 5 groups, A, B, C, D, and E. So I got 15 students in each group. Right, now let's say all of my students had an exam on statistics, and here are the grades for my students on a 5-point scale, okay? So one student scored 1 out of 5, the second student scored 4 out of 5, and so on. Now I want you guys to stop this video and build a histogram for each group. Okay, so you should have 5 histograms in your notebook. Now here are the histograms showing the grades of the students in all the 5 groups, in groups A, B, C, D, and E. Now compare all the 5 histograms here. How are they different from each other? Well, as you can see here, they all have different shapes. Okay, now please write this down. If the columns on the right side are taller than the columns on the left side, then we say that the graph has a skewed left distribution. Now, if the columns on the left side are taller than the columns on the right side, then we usually say that the distribution is skewed right. Okay? Now, if the left half of your graph is identical to the right half, then we usually say that the graph has a symmetric distribution. Okay? Now, if the graph is symmetric and has a shape of a mountain like this, then the distribution is considered as bell-shaped, right? Now, if all the columns are of the same height, then we usually claim that the graph has a uniform distribution. Hey guys, in this video I want to show you how to calculate the average and median based on a graph like this. I'll give you an example. Let's say all of my students are divided into 3 groups, A, B, and C. And let's say this graph is showing the ages of my students in group A. So I can see here in this graph that 2 of my students are 20 years old, 1 student is 25 years old, and 4 of my students are 30 years old. Now, if I ask you to calculate the average and median for this graph, what are you going to do? Some students think that calculating the average is quite easy. It's just 20 plus 25 plus 30 divided by 3, which gives them 25. Well, that's wrong actually. When calculating the average for a graph, you have to consider the total number of people shown in the graph. I can see 7 dots here in this graph. That means group A has 7 students. So to calculate the average, I have to sum up the ages of all the 7 students and then divide that sum by 7. So it's 20 plus 20 plus 25 plus 30 plus 30 plus 30 plus 30 divided by 7. That gives me 26.43. This is the average age for group A. Now, same can be said about the median. When calculating the median, you have to consider the total number of people in the group. Now, some students think that the median is 25 because this number is right in the middle. It's wrong. Why? You have to put the ages of all the 7 students in ascending order, and only in that case you'll be able to calculate the median. So I put the ages of all the 7 students in ascending order here, and I found the number right in the center is 30, so that means the median is 30, it's not 25. Same for the second graph. So if I ask you to calculate the average for group B, you have to sum up the ages of all the 6 students here. So it's 20 plus 20 plus 20 plus 25 plus 25 plus 30 divided by 6. That gives me 23.33. That's the average for group B. And same for the median. When calculating the median, please consider the total number of people in the graph. You have to put the ages of all the 6 students in ascending order, just like I did over here, and then find the number in the center. It's 22.5. The average for group C is 20 plus 20 plus 20 plus 25 plus 25 plus 30 plus 30 plus 30 divided by 8. That's equal to 25. And the median for it is 25 as well. I put the ages of all the 8 students in ascending order here, and I found the number in the middle. It's 25. Now, same can be said about the histograms over here. So if I ask you to calculate the average and median for this histogram, please consider the total number of people. Now, let's assume that this graph is showing the grades of my students. First of all, I have to find the total number of students. For that, I just have to sum up the frequencies for all the values. So it's 3 plus 3 plus 2 plus 1 plus 1. That's equal to 10. That means the total number of people in this graph is equal to 10. So I have to sum up 10 numbers and then divide that sum by 10 in order to get the average. So it's 1 plus 1 plus 1 plus 2 plus 2 plus 2 plus 3 plus 3 plus 4 plus 5 divided by 10. That gives me 2.4. Now to find the median, I have to put the grades of all the 10 students in ascending order and then find the number in the center. It's equal to 2. So we're going to have to use the same technique for the second histogram and the third histogram over here. To find the average and median, these histograms, I summed up the grades of all the 10 students and then divided the sum by 10. And to find the medians, I put the grades of all the students in ascending order, and then I found the number right in the center. Now, as you can see here in these 3 graphs, the average and median for the first graph, for the first histogram, please compare the average to the median in the first histogram. The average here is greater than the median. The average for the second histogram is less than the median, whereas the average for the third histogram is equal to the median. Why? Well, it all depends on the shape of the distribution. Please write this down. If the distribution, if the graph is skewed right, then the average is going to be greater than the median. As you can see here, the first histogram is skewed right. That's why the average is greater than the median. Now, if the distribution is skewed left, then the average is going to be less than the median, just like here. As you can see, the shape is skewed left. That's why the average is less than the median. Now, if the histogram is symmetric, if the graph is symmetric, then the average is going to be equal to the median. Just like you can see here, this distribution over here is bell-shaped, it's symmetric. That's why the average is equal to the median. And please remember that if the graph is symmetric, then you don't really have to calculate the average, try to find the median. Both average and median are going to be right in the center, just like here. I'll give you one more example. As you can see, this dot plot over here is symmetric. That's why you don't even have to calculate the average or median. Just know that the average and the median are going to be right in the center over here. And please remember that the average is going to be equal to the median if your graph is symmetric. Hey guys, in my previous lesson I explained how to build graphs. In this video I want to explain how to describe them. Okay? So if I ever ask you to describe a graph, please follow this format. Describe the center, spread, and shape. Now to describe the center, calculate the average or the median. Now to describe the spread, just state where the distribution starts and where it ends. And to talk about the shape, just state if the distribution is skewed right, skewed left, or symmetric. I'll give you an example. Let's say I have 12 students in my class, and this graph is showing the ages of my students. So one student is 18 years old, 2 students are 19, 3 of them are 20 years old, and so on. So in total, I got 12 students in my class. Now, if I show you this graph, this kind of a graph on the exam, and say, describe the graph, then follow this format, okay? First of all, describe the center. Again, just like I said, to describe the center, you have to calculate the average or the median. Let's go with the average, okay? Now, to calculate the average, you don't really have to sum up the ages of all the students and divide the sum by 12, because the graph is symmetric. Since the graph is symmetric, I know that the average is going to be right in the center over here, which is 20.5. So I'm going to state here that the average is equal to 20.5. Now to describe the spread, we just have to state where the distribution starts. It starts at the value 18 and it ends at the value 23. So we're going to say that here. The distribution starts at 18 and ends at 23. Now we have to describe the shape of the distribution. Okay? Here you just have to state if it's skewed right, skewed left, or symmetric. I can see that the distribution is symmetric. We can say that it's symmetric, or we can just say that it's bell-shaped, because it looks like a mountain, it looks like a bell. So I'm going to write that the distribution is symmetric. I'll give you one more example. Let's say some kind of a city has, let's say, 12 restaurants, and this graph is showing the number of employees in those restaurants. So I can see here in this graph that 3 restaurants have 1 employee, 3 of them have 2 employees, 2 of them have 3 employees, and so on. Now, if I show this graph, this kind of a graph on the exam, and say describe the graph, then in this case you just have to again describe the center, spread, and shape. Start with the center. Now, to describe the center, again, you have to calculate the average or the median. Let's go with the median, okay? I know that the median here is equal to 2.5. How do I know? Because I know that the total number of restaurants over here is 12, because you sum up all the frequencies over here, you will get 12. And so we know that the median is at the 50th percentile. That means 50% of the subjects are to the left from the median, and the other 50% are to the right from the median. I know that 6 of the restaurants are to the left from 2.5, and the other 6 are to the right from 2.5. That means 2.5 is the median. Now let's describe the spread. Again, we just have to state, here we just have to state that the distribution starts at 1 and ends at 7. So we're just showing the minimum and the maximum value. So I'm going to say that here, the distribution starts at 1 and ends at 7. Now what can we say about the shape? Well, I can clearly see here that the shape is skewed right. We're just going to say skewed right here. Okay. As you can see, it's quite easy. Don't forget to describe the center, spread, and shape when describing a certain graph. Hey guys, in this video I want to explain why you have to focus on the center, spread, and shape when describing a certain graph. I'll give you a very small example. Let's say I got 50 students in my class, and they all had an exam on statistics, and the next day the dean of the faculty calls me and says, hey, how did your students do on the exam? And let's imagine that I said, well, the average score is 60. The distribution starts at 40 and ends at 90, and the shape of the distribution is skewed right. Now the dean has a very clear understanding about the exam results. Now he can imagine a graph where the columns start at 40 and end at 90. And he knows that the columns on the left side are taller than the columns on the right side. Why? Because I said that the distribution was skewed right. So now the dean knows that most of the students have very low scores. That means most of the students did a very bad job on the exam. Now, but what if I say the average score is 75, the distribution starts at 40, ends at 90, and the shape of the distribution is skewed left. So now the dean is going to imagine a graph like this where the columns start at 40, end at 90, the average is 75, and he knows that the columns on the right side are taller than the columns on the left side, because I said that the distribution was skewed left. So that means most of the students have very high scores, and that also means that most of the students did a very good job. One more example. Let's say the average, I said that the average score is 65, the distribution starts at 40, ends at 90, and the shape of the distribution is bell-shaped. Let's say the distribution is bell-shaped like this. So now he's going to imagine a graph that is bell-shaped like this, where the bell starts at 40, ends at 90, the average is right in the center, it's equal to 65, and so he knows that most of the students have average scores. That means most of my students did an average job. So you see, just by describing the center, spread, and shape, I'm giving the dean a very clear understanding about the exam results. Now he has a very clear picture of what's going on in my class, and now he knows how my students are doing. Okay guys, in this video I want to talk about the difference between a population and a sample. What's a sample? A sample is basically a small piece of a population. Based on a sample, we usually make a conclusion about the whole population. I'll give you an example here. Let's say I'm a sociologist and I want to know what % of Americans are going to vote for Trump next year. Now, I know that the population of America is approximately 300 million people. I can't survey all the 300 million people to find out what % of them are going to vote for Trump. So what's my option? What can I do here? Well, I can choose a small group of, let's say, 500 or 1,000 Americans, and I can survey them. Let's say I decide to choose a small group of, let's say, 1,000 Americans, and I ask each one of them if they're going to vote for Trump or not. In this context, this small group of 1,000 Americans is my sample, whereas all the Americans, I mean all the 300 million people staying in America, is my population. This is a small piece of this. 1,000 is a small piece of 300 million, and based on this small piece, I mean on this sample, we're making a conclusion about the whole population. Let's say if out of the 1,000 Americans surveyed, 75% say they're going to vote for Trump, then I'm going to assume that approximately 75% of all the Americans, of all the 300 million people staying in America, are going to vote for Trump. So based on my sample, I'm making a conclusion about the whole population. I hope it's clear. I'll give you one more example here. Let's say I want to know what % of KBTU students prefer to study online. Well, let's assume that the population of KBTU is 3,000 students. Let's assume that KBTU has 3,000 students in total. Now, I can't survey all the 3,000 KBTU students. I don't have time for it. So I decide to choose a small group of, let's say, 100 KBTU students, and I ask each one of them if they prefer to study online or not. In this context, this group of 100 KBTU students is a sample, whereas all the KBTU students, I mean all the 3,000 students going to KBTU, is the population. So based on this small sample, I'm going to make a conclusion about the whole population. Let's say if out of the 100 students surveyed, let's say 20% say they prefer to study online, then I'm going to assume that approximately 20% of all the KBTU students, of all the 3,000 students going to KBTU, prefer to study online. Based on my sample, again, I'm making a conclusion about the whole population. Let me give you one more example. Let's say I'm a psychologist, and in my research, I want to prove that classical music has a positive effect on the child's intellect. What I'm trying to prove here is that the more a child listens to classical music, the smarter he becomes. So it means if you listen to classical music, you're going to become more intelligent. Now, in order to prove my position, in order to prove this theory, I decide to conduct an experiment. Let's say I choose a small group of 25 kids, and I make them all listen to classical music for, let's say, for 1 month. And at the end of the experiment, let's say 1 month later, I check their level of intellect. Okay? And it turns out that this group of 25 kids became smarter after listening to classical music. So based on this result, I conclude that all kids become smarter when they listen to classical music. Well, as you see here, in this context, this group of 25 kids that I conducted my experiment with is a sample, whereas all the kids, I mean, all the kids living on this planet is basically the population. So based on this small group of 25 kids, I'm going to make a conclusion about all kids. So based on a sample of 25 kids, I'm making a conclusion about the whole population of kids, I mean, about all kids living on this planet. Okay. I hope it's clear. Now please write this down. the total number of people in the population is called the population size, and the symbol we use for it is a big letter N. Now, the total number of people in the sample is called the sample size, and the symbol for it is a small letter n. Now, if you calculate the average for the population, it's going to be called the population mean. The symbol for it is mu. Now, if you calculate the average for the sample, it's going to be called the sample mean, and the symbol used for it is an x bar. I'll give you an example. Let's say the population of KBTU is 3,000 students. Okay. Suppose that KBTU has 3,000 students in total. Now, let's imagine that I want to know the average GPA for all the KBTU students. Now, you understand that in order to calculate the average for all the KBTU students, I mean the average GPA for all the KBTU students, basically I have to know the GPAs of all the 3,000 students going to KBTU. And then I have to sum up the GPAs of all the 3,000 students and then divide that sum by 3,000. Then in that case, I'm going to know what the average GPA for the KBTU students is. But since I don't know the GPAs of all the 3,000 students, I decide to choose a sample of, let's say, 50 KBTU students, and I survey them. Let's say I enter the building of KBTU and I survey the first 50 students that I meet in the hall. And I ask each one of them what his or her GPA is, and then I calculate the average for this group of 50 KBTU students. So I sum up the GPAs of the 50 students and I divide that sum by 50, and let's assume I get 3.0. Now let's imagine that someone else knows the GPAs of all the 3,000 KBTU students. Okay, so he sums up the GPAs of the 3,000 students, divides the sum by 3,000, and he gets 3.2. Well, in this context, guys, this group of 50 students surveyed is my sample. Okay, the symbol for it is a small letter n. Whereas all the KBTU students, all the 3,000 students going to KBTU is the population. The symbol we use for it is a big letter n. Now, 3.0 is an x bar. Why? Because this is the average GPA for the 50 KBTU students. This is the average for the sample. That's why it's called a sample mean. Whereas 3.2 is the population mean. It's a mu. Why? Because this is the average GPA for all the 3,000 KBTU students. This is the average for the population. That's why the symbol for it is mu, which is the population mean. Let me give you one more example. Let's say I want to know the average income for all the people, for all the Almaty residents, for all the people staying in Almaty. Let's imagine that the population of Almaty is approximately 1.5 million people. Now, in order to know the average income in Almaty, in order to find the average salary for all the people staying in Almaty, I have to know the incomes of all the 1.5 million people living in Almaty area. Now, let's say I cannot survey all the 1.5 million people staying in Almaty, so I decide to choose a small sample of, let's say, 100 Almaty residents, of 100 people staying in Almaty, and I ask each one of them what his or her income is, and then I sum up the incomes of the 100 people surveyed, and I divide the sum by 100, and I get, let's say, $500. Let's assume that someone knows the incomes of all the people staying in Almaty. He sums up the incomes of 1.5 million people, divides the sum by 1.5 million, and he gets $600. Well, in this context, this group of 100 people staying in Almaty is my sample. This is the population, the sample size. Whereas 1.5 million people staying in Almaty, all the people staying in Almaty is the population size. This is my population in this context. Whereas $500 is an X bar. This is a sample mean. Why? Because this is the average salary for 100 people, for 100 Almaty residents. Okay, so this is the average for the sample. That's why this 500 is a sample mean. Whereas $600 is the population mean. Why? Because this is the average for all the people staying in Almaty. That's why $600 is a population mean. So I hope you guys are not confused. So $500 is basically a sample mean, where $600 is a population mean. Why? Because 500 is the average for 100 people in my sample, whereas this is the average for all the people staying in Almaty. Hey guys, in this video I want to talk about a standard deviation. I want to explain what a standard deviation is using an example. Let's say I have 5 students in my class and they all had an exam of statistics, and here are the exam scores of my students. One student scored 2 out of 10, the second student scored 4 out of 10, this guy scored 6 out of 10, and the rest of the students scored 8 and 10 out of 10. Now here's the graph showing the exam scores of my students, and I also showed the average score for this group on this graph. Well, to calculate the average, I just summed up the exam scores of all the 5 students and I divided that sum by 5 and I got 6. So here's the average score for my group of 5 students. Now let's say I want to know how far each student is from the average. Basically, I want to find the distance, I want to calculate the distance between the score of each student and the average score. Well, in statistics, the distance between a certain value and the average is called a deviation. Again, what's a deviation? A deviation for a certain value is a distance between that value and the average. Or you can put it this way, a deviation is basically a difference between a certain value and the average. For example, the deviation for the value 2, this value 2, is 2 minus 6, which is minus 4. That means the distance between this value and the average is equal to 4. Well, the deviation over here has a negative sign. Why? Because 2 is less than the average, is to the left from the average in the graph. That's why this value has a negative deviation. The deviation for the value 4 is equal to 4 minus 6, which is minus 2. That means the difference between this value and the average is equal to minus 2. Again, it has a negative sign. Why? Because it's less than the average. The deviation for the third value, which is 6, is equal to 6 minus 6. That is 0. That means 6 is no different from the average score. There is no difference between 6 and the average score. This is how you can think of it. Now, the deviation for the value 8 is 8 minus 6, which is plus 2. That means the distance between the value 8 and the average is equal to 2, and it has a positive sign. Why? Because 8 is greater than the average. And the deviation for the last value is 10 minus 6. That gives me plus 4. That means the difference, or, well, actually, there is no difference between the word difference and the distance here. If the deviation for the value 10 is plus 4, that means the difference between this value and the average is equal to 4, and has a positive sign, has a positive deviation. Why? Because 10 is greater than the average. So as you can see here, I calculated 5 deviations. I calculated 5 differences, 5 distances. I calculated the distance between each value and the average here. Now, let's say I want to calculate the average for all these 5 deviations. But here's the problem. If I calculate the average for all the deviations, I will get 0. Why? Because all the negative values are going to cancel out the positive values and I will get 0. Now, how can I avoid 0? Well, to avoid 0, I can take the absolute values of all these deviations and then sum them all up and then divide that sum by 5, and that way I will get the average for all these 5 deviations. Or I can square all the 5 deviations, right? Square all the 5 deviations, then sum them all up, and then divide that sum by the total number of deviations, which is 5, and then take the square root of it. That's going to be called a standard deviation. So in order to find the standard deviation, you just have to square all the deviations, just like I did over here. Sum them all up, divide that sum by the total number of people, which is 5, and then take the square root of the result. In this case, the standard deviation is equal to 2.8. That means the average deviation between all the students and the average is equal to 2.8. Or you can put it this way, you can think of it this way. The average difference between all the scores of all the students and the average score is equal to 2.8. So please remember that the standard deviation shows the average distance between all the values and the average value. Or you can think of it this way, it shows the average difference between all the values and the average value. Guys, I want to give you some more examples to explain what I mean by a standard deviation. Okay, here's an example. Let's say I have 50 students in my class and they all had an exam on statistics. And now the average score for this group is 60 out of 100 and the standard deviation for all the scores is 10. Now, if the average score for this group of 50 students is 60, it doesn't mean that all the 50 students scored exactly 60, right? If, for example, one student scored 70, that means the difference between his score and the average score is equal to 10. Now, if someone scored, let's say, 55, then it means that the difference between his score and the average score is equal to 5. And if I scored, let's say, 90 out of 100, then it means that the difference between my score and the average score is equal to 30. Now, what's the average difference between the scores of all the students and the average score? Well, the average difference between the scores of all the 50 students and the average score is equal to 10. This is how you can think of a standard deviation. Or you can think of it this way. If I scored, let's say, 75, then it means that my score differs from the average score by 15. If someone scored 45, or let's say 50, then it means that his score differs from the average score by 10. Now, how do the scores of all the students differ from the average score on average? Well, on average, the scores of all the students differ from the average by 10. This is how you can interpret the standard deviation in this context. Or if it's still hard for you to understand what I mean by a standard deviation, you can think of it this way. A standard deviation shows how far we are from the average. Now, it shows how far all these 50 students are from the average score over here. For example, let's say if for instance, the standard deviation for the scores of all the students is equal to 1, then it means that the scores of all the 50 students are very similar to the average score. If you build a graph that shows the scores of all the 50 students, then you will see in this graph that all the students are very close to the average score. They're just clustered around the center. Now, if, let's say, the standard deviation is equal to, let's say, 30, then it means that the scores of all the 50 students, the scores of the students are quite different from the average score. The scores of the students are quite, I would say, far from the average score. They're more spread out. They're more spread away from the average in the graph. So if you build a graph that shows the scores of all the 50 students, you will see in this graph that the students are more spread out. The scores of the students are more spread out. They're further away from the average, from the center. Okay, so the smaller is a standard deviation, the closer we are to the center, the bigger the standard deviation, the greater is the standard deviation, the further we are away from the center. The more spread out we are, the more spread out, spread away the scores are from the center. I'll give you one more example here. Let's say the average salary in America is $3,000 and the standard deviation is equal to $1,000. Now, if the average salary for all the Americans is equal to $3,000, it doesn't mean that all the Americans make $3,000, right? Exactly $3,000. If my salary is, let's say, $4,000, then the difference between my salary and the average salary is equal to $1,000. If someone else's salary is $5,000, then the difference between his salary and the average salary is equal to $2,000. Now, here's the question. What's the average difference? What's the average distance or the average difference between the salaries of all the Americans and the average salary? Well, it's equal to $1,000. So on average, the salaries of all the Americans differ from the average by $1,000. This is how you can think of the standard deviation. If it's still hard for you to understand what I mean by a standard deviation, you can think of it this way. If I move to America, I'm going to earn $3,000, on average, I'm going to earn $3,000 plus minus $1,000 on average. Okay, so if I move to America, it doesn't actually mean that I will make exactly $3,000 if the average salary in America is $3,000. How is my salary going to be different from the average salary? We don't know exactly how different your salary, my salary is going to be from the average salary, but on average, my salary is going to be different from the average salary by $1,000. Here's one more example. If I ask you guys, how much is an apartment in Almaty, you're probably going to say, well, a one-bedroom apartment in Almaty is approximately is $50,000 plus minus, let's say, $5,000. So a one-bedroom apartment in Almaty is on average $50,000 plus minus $5,000. So when you say $5,000 here, plus minus $5,000, you actually mean a standard deviation. We usually use a standard deviation when we are not sure about something. So we're not sure if the apartment is going to be exactly $50,000, but it's going to be around $50,000 plus minus $5,000. So by plus minus $5,000, we mean a standard deviation. That means all the one-bedroom apartments differ from the prices for all the one-bedroom apartments in Almaty differ from the average price by $5,000 on average. Hey guys, in this video I want to show you how to calculate a standard deviation. Please write this down. A standard deviation is of two types, a population standard deviation and a sample standard deviation. Now, if you calculate a standard deviation for a population, it's going to be called the population standard deviation. Now, the symbol we use for it is sigma. Now, if you calculate a standard deviation for a sample, it's going to be called a sample standard deviation, and the symbol we use for it is S. Now, here's the formula for the population standard deviation. This formula is basically showing you that if you want to calculate the population standard deviation, you have to subtract the value of each subject from the average. Then square all the differences, and then sum up all the squared differences, and divide that sum by the total number of people in your population. And at the end, take the square root of the result. Now, this formula is showing you that if you want to calculate the standard deviation for a sample, you have to subtract the value of each subject from the average, then square the differences, sum up all the squared differences, and divide the sum by the total number of people in your sample minus 1, and take the square root of the result. As you can see, these two formulas are very similar to each other. The only difference is that when calculating the sample standard deviation, you have to subtract 1 from the sample size, from the total number of people in your sample. But when calculating the standard deviation for a population, you don't have to subtract 1 from the population size. You don't have to subtract 1 from the total number of people in your population. Now, the reason for it is related to the topic called a degree of freedom. We didn't study this topic yet. That's why, for now, forget about the why question and just keep in mind that when calculating a sample standard deviation, you have to subtract 1 from the sample size. And also, please remember that in this course, we're not going to calculate a standard deviation for a population. Why? Because it takes a very long time. Populations are usually very huge. If you want to calculate the standard deviation for the salaries of all the Americans, then you will have to know the salaries of all the 300 million people staying in America, and then subtract the salary of each American from the average salary. So you'll have to basically find 300 million differences, square those differences, and divide that sum, the sum of those squared differences by the total number of people, which is 300 million, and then take the square root of the result. That takes a very long time. That's why in this course, we're going to calculate a standard deviation for small samples only. So we're going to use this formula only. I'll give you an example, guys. Let's say I got 5 students in my class, and they all had an exam on statistics, and here are the exam scores of my students. I want to calculate the standard deviation for the sample. I want to calculate the standard deviation for the exam scores of my students. Now, before I start calculating the standard deviation, I have to find the average. It's very easy. I just have to sum up the scores of all the students and then divide that sum by the total number, which is 5, because I got 5 students in my group. So the average here is equal to 65.6. Now, in order to calculate the standard deviation for this group, I have to subtract the exam score of each student from the average score and then square that difference. So it's 60 minus 65.6 squared plus 55 minus 65.6 squared plus 55 minus 65.6 squared plus 78 minus 65.6 squared plus 80 minus 65.6 squared divided by the total number of students, which is 5, minus 1. So we take the square root of the result and we get 12.42. So the standard deviation for the exam scores of my students is equal to 12.42, whereas the average is 65.6.
Guys, in this video lesson, I want to show you how to calculate the standard deviation for a graph. Here's an example. Let's say this graph is showing the scores of my students on a 10-point scale. Let's say the average score is equal to 5 and the standard deviation is equal to 1.22. Now, how did I calculate the standard deviation? Please remember that when calculating a standard deviation for a graph, you have to take into account the total number of people. This graph is showing 9 dots. That means I have to calculate 9 differences, square all those 9 differences, sum them all up, and then divide that sum by 9 minus 1. So it's 3 minus 5 squared plus 4 minus 5 squared plus 4 minus 5 squared plus 5 minus 5 squared plus 5 minus 5 squared plus 5 minus 5 squared plus 6 minus 5 squared, just like I did here, plus 6 minus 5 squared plus 7 minus 5 squared. So I calculated 9 differences, you see. I squared them all and I summed them all up and then divided that sum by the total number of dots, the total number of people in my class, minus 1. Then I took the square root of this result and I got 1.22. So the standard deviation for this graph is equal to 1.22. Now compare all the 4 graphs over here. As you see, all the 4 graphs have the same average, but they all have different standard deviations. You see? As you can see, this graph has the lowest standard deviation, that's equal to 0. And this one has the highest standard deviation. The standard deviation for the second graph is lower than the standard deviation for the first graph. The standard deviation for the third graph is less than the standard deviation for the second graph. And this one has the smallest standard deviation. Now, why? Because the standard deviation depends on the spread. Just like I said in my previous video lesson, the closer we are to the center, the smaller is the standard deviation. The further we are from the center, the greater is the standard deviation. So please remember, the more people are closer to the center, the smaller is the standard deviation. The further are people from the center, from the average, the greater is the standard deviation. Now, if the standard deviation is equal to 0, that means all the people have the same value. Well, in this context, all the students have the same score, which is equal to 5. That's why the standard deviation is equal to 0. Here's one more example, guys. Here's one more exercise to complete. Let's say these 3 graphs are showing the grades of students in 3 different groups. As you see, all the 3 graphs have the same average, it's equal to 3. Now, all the 3 graphs have the same spread. When I say spread, I mean the distance between the lowest value and the highest value. As you can see here, in all the 3 graphs, the distance between the highest and the lowest value is equal to 4. 5 minus 1 is equal to 4. Well, now, despite the fact that all the 3 graphs have the same average and have the same spread, they all have different standard deviations. This graph has the smallest standard deviation, and this one has the highest standard deviation. Well, so what's the conclusion here? Well, it means that the more people are away from the center, the greater is the standard deviation. The more people are closer to the center, the smaller is the standard deviation. This graph has the highest standard deviation. Why? Because all the students here are as far as possible from the center, from the average. Now, this graph has a small standard deviation. Why? Because this graph has only 2 students that are as far as possible from the center. All the rest of the students are close to the center. That's why the standard deviation for this graph is much smaller than the standard deviation for this one, despite the fact that all the 3 graphs have the same spread. So please remember, the bigger is the spread, the greater is the standard deviation. Now, the more people are further away from the center,
the greater is the standard deviation. So I guess the size of the standard deviation depends on two factors. The first one is the spread, right? And the second factor is the number of people that are far away from the center.
Hi, in this video we're going to talk about a z-score. What's a z-score? Please write this down. A z-score is the number of standard deviations between a certain value and the mean. To calculate the z-score for a certain value, you have to subtract that value from the average, which is the mean, and then divide that difference by the standard deviation. Here's an example. Let's say this graph is showing the IQ scores of 7 people. Okay. Now the average IQ score in this group is 110. Now the standard deviation is 8.66. Now let's imagine that I want to calculate the z-score for this value, for the value 100. For that, I have to subtract 100 from the average, which is 110, and divide the difference by the standard deviation, which is 8.66. And I got minus 1.15. It means that 100, the value 100 is 1.15 standard deviations less than the average. Or you can think of it this way: the distance between the value 100 and the average is equal to 1.15 standard deviations. Now, this value has a negative z-score. Why? Because the value 100 is less than the average. I mean, it's to the left from the average. That's why it has a negative sign. Now, the z-score for the next value, for 105, is equal to 105 minus 110 divided by 8.66, which is equal to minus 0.57. That means 105 is 0.57 standard deviations less than the average. The distance between 105 and the average is equal to 0.57 standard deviations. Again, this value has a negative sign. Why? Because 105 is less than the average. So if the z-score for 105 is equal to minus 0.57, that means 105 is 0.57 standard deviations less than the average. Now the z-score for the average itself is going to be equal to 0, because 110 minus 110 divided by 8.66 gives me 0. That means 110 is 0 standard deviations away from the average. So it's no different from the average. There's 0 standard deviations between 110 and the average. Now the z-score for the next value, 115, is 115 minus 110 divided by 8.66, which is plus 0.57. That means 115 is 0.57 standard deviations greater than the average. So the distance between this value and the average is equal to 0.57 standard deviations. Again, this value has a positive z-score. That means 115 is 0.57 standard deviations greater than the average. It's to the right from the average. That's why this value has a positive z-score. The z-score of the last value, 120, is equal to plus 1.15. That means 120 is 1.15 standard deviations greater or higher than the average. So the distance between this value and the average is equal to 1.15 standard deviations. Now, as you can see, we usually use a z-score to calculate how many standard deviations we have between a certain value and the average. So the z-score for a certain value shows how many standard deviations this value is away from the average. Hey guys, in this video lesson I want to show you how to build a graph that shows the relationship between two variables. Actually, when you were at high school, you guys studied this kind of graphs that show the relationship between the variables x and y, where the variable x is called an independent variable and the variable y is called a dependent variable. And this line shows the relationship between the variables x and y. And you guys remember from high school that this line is based on the equation a plus bx. Now here in this course, here in statistics, this line is called a regression line. Whereas this equation is called a regression equation, where A is a y-intercept and B is called a slope. Sometimes we call it a regression coefficient. Now, what's A?
I mean the y-intercept. Now A, I mean the y-intercept, usually shows the value of y when x is equal to 0. For example, here in this graph, you can see that when the variable x is equal to 0, the variable y takes on the value a. So the y-intercept, I mean a, is basically the starting point of the regression line. This is the point where the regression line starts moving up. Whereas b, I mean the slope, shows how y increases each time x increases by 1 unit. I'll give you an example just to make it clear. Let's say my equation is 2 plus 3 times x. Here in this equation, the slope is equal to 3, whereas the y-intercept is equal to 2. Now, if the y-intercept is equal to 2, that means the variable y is equal to 2 when x is equal to 0. You can confirm it here in the graph. As you can see here, when x is equal to 0, the variable y takes on the value 2. And 2 is basically the starting point of the regression line. This is the point where the regression line starts moving up. Okay, now the slope is equal to 3. That means each time x increases by 1 unit, y increases by 3 units. Here's a proof for it. Just put in 1 instead of x over here. Then in that case, y is going to equal 2 plus 3 times 1, which is 5. You can confirm it here in the graph. So when x is equal to 1, y is equal to 5. Okay. Now put in 2 instead of x. So if x is equal to 2, then y is equal to 2 plus 3 times 2, which is 8. And you can confirm it here in the graph. This regression line is showing me that when x is equal to 2, the variable y is equal to 8. Now put in 3 instead of x. Then y is going to equal 2 plus 3 times 3, which is 11. That means when x is equal to 3, y is equal to 11. Confirm it here in the graph. So here the regression line is showing me that when x is equal to 3, y is equal to 11. Okay, so as you can see here, each time x increases by 1 unit, the variable y increases by 3 units. Okay, this is what the slope is showing me. So if the slope is equal to plus 3, that means each time x increases by 1 unit, y increases by 3 units. Now, please remember that if the slope is negative, if the slope is less than 0, then it means that the regression line is going down. And it means that each time x increases, y actually decreases. Here's an example. Let's say my equation is 20 minus 3 times x. Well, in this equation, the y-intercept is equal to 20. That means the starting point of the regression line is equal to 20. So if x is equal to 0, the variable y is going to equal 20. You can check it here in the graph. So when this graph is showing me that when x is equal to 0, y is equal to 20. That's the starting point of the regression line. That's the point where the regression line starts going down this way. Now, the slope in this equation is equal to minus 3. That means each time x increases by 1 unit, the variable y decreases by 3 units. Here's a proof for it. So put in 1 instead of x, then y is going to equal 20 minus 3 times 1, which is 17. That means when x is equal to 1, the variable y is equal to 17. And you can confirm it here in the graph. This line is showing me that when x is equal to 1, y is equal to 17. Now, what if x is equal to 2? Well, in this case, y is going to equal 20 minus 3 times 2, which is 14. That means when x is 2, y is 14. This dot has a y value of 14 and an x value of 2. So this line is showing me that when x is equal to 2, y is equal to 14. Now, what if x is equal to 3? Then y is going to equal 20 minus 3 times 3, which is 11. So it means when x is equal to 3, the variable y should equal 11. So you can check it here in the graph. As you can see here, this line is showing me that if x is equal to 3, then y is going to equal 11. Okay, now please write this down. If the slope is equal to 0, then it means that y is constant. It doesn't change no matter what value the variable x is going to take on. So if the slope is equal to 0, then the regression line is going to be parallel to the x-axis over here. I'll give you an example. Let's say that the equation is 3 plus 0 times x. It means the variable y is always going to equal 3, no matter what value the variable x is going to take on. So if x is equal to 1, y is equal to 3. If x is equal to, let's say, 2, then y is still equal to 3. If x is equal to, let's say, 5, the variable y is still going to equal 3. So you can see it here in this graph. Each time x increases by 1 unit, y doesn't change. It's constant. So please remember that if the slope is positive, if the slope is greater than 0, then it means that the regression line is going up this way. And that means that each time x increases, y increases as well. In this case, we usually say that there is a positive relationship between x and y. Now, if the slope is negative, if the slope is less than 0, then it means that the regression line is going down. Okay? And it also means that each time x increases, y decreases. In this case, we usually say that there is a negative relationship between the variables x and y. Now, if the slope is equal to 0, then it means that the line, the regression line, is parallel to the x-axis. And that also means that each time x increases, y, the variable y, doesn't change. In this case, we usually say that there is no relationship between the variables x and y. Hey guys, in this video lesson, I want to explain the intuition behind the regression equation. I'll give you an example. Let's say I'm a sociologist and I want to build a regression equation that shows the relationship between years of education and income. In this context, income is the variable y and years of education is the variable x. We know that usually the more educated you are, the more money you make. I mean, the higher is your level of education, the higher is your income. So this regression equation is going to show me how a person's income increases when his level of education increases. Now, in order to build the regression equation, first of all, I have to survey a sample. Let's say I surveyed a sample of 6 people. I asked each one of them how many years of education they had and how much money they made. And the first person says he has 11 years of education. That means he went to school, to elementary school and high school for 11 years, but he never went to college. Now his income is $2,100 a month. The second guy says he has 11 years of education. That means he went to elementary school and high school for 11 years, and his income is $2,500 a month. This guy says he has 12 years of education. That means he went to school for 11 years, then he went to college for 1 year and quit. Now his salary is $2,300 a month. This guy has 13 years of education. He went to school for 11 years and he went to college for 2 years. Now he's working and making $2,500 a month, and so on. Now this table is showing me the years of education and incomes for all the 6 people in my sample. So this table is showing the x and y coordinates. It's showing the x and y values for each person in my sample. Now I built a table that shows the x and y values. Now what's my next step? The next step is to build a graph that shows the x and y coordinates for all the people in my sample. Since I got 6 people in my sample, this graph is showing 6 dots. And each dot represents a certain person from my sample. Each dot shows the x and y values for each person in my sample. Okay. Now this graph is called a scatter plot. Now what is a scatter plot? A scatter plot is a graph that shows the relationship between the variables x and y. It shows how how y increases or decreases each time x increases. Okay. Now, I built a table showing the x and y coordinates. Then I built a scatter plot showing the x and y coordinates for all the people in my sample. Now, what's my next step? Well, the next step is to use some kind of a statistical software. Some kind of a statistical program like Excel or Stata. Let's say I decide to choose Excel, so I open up Excel and I type in the x and y values for all the people in my sample, and I ask Excel to build the regression equation for me. Now, well, in that case, Excel is going to build a scatter plot like this with 6 dots, and then Excel is going to try to build a regression line that goes through the middle of this trend. So Excel is going to try to build a regression line that goes through the middle of this dots. It will choose the starting point and the slope. In this case, the slope symbolizes the angle. It will try to choose the starting point, I mean the y-intercept, and the slope in such a way that the line goes through the middle of the 6 dots. It will choose the starting point and the slope so that the regression line stays as close as possible to all the 6 dots. I'll say it one more time. Excel is going to choose the y-intercept, which is the starting point, and the slope, which is the angle, in such a way that the regression line stays at the closest possible distance to all the 6 dots that I showed here. Okay, and then Excel is going to give out a regression equation. So let's imagine that I opened Excel, I typed in the x values and the y values for all the 6 people in my sample, and I asked Excel to build the regression equation. Well, in that case, Excel is going to build a scatter plot like this, build a regression line that is as close as possible to all the 6 dots, and then Excel is going to give out the regression equation. Let's say Excel gives me this equation, y hat equals 100 plus 200 times x. Okay, well, in this context, the y-intercept is equal to 100. That means the starting point of this line is equal to 100. It means that y is equal to approximately 100 when x is equal to 0. In this context, that means for 0 years of education, income equals approximately $100. So people who have 0 years of education, I mean people who don't have any education at all, people who never went to school, are going to make approximately $100 a month. That's what it means in this context. Now the slope is equal to 200. That means each time x increases by 1 unit, y increases by approximately 200 units. In this context, it means each time a person gets 1 more year of education, his income goes up by approximately $200. So if you study for 1 more year, your income is going to go up by approximately $200. This is how you can interpret the slope in this context. And when interpreting the y-intercept in this context, you can say if you don't have any education, you're going to make approximately $100 a month. Now, if you don't have any access to Excel, if you want to use your smartphones for building a regression equation, then you can use some kind of a statistical website. I can recommend this website. Please go to socstatistics.com and then click on the option called calculator, and the website is going to give you a list of calculators, and from that list please choose the linear regression calculator. And then the website is going to show you a table for the x and y values. Then type in the x and y values in that table and then click the OK button. And the website will build a scatter plot for you and then give out the regression equation like this one. Now I want to explain some of the basic terms related to the regression equation. Now please write this down. The y value for a certain dot is called an observed value. For example, the y value for this dot is 2,500. That's an observed value. Now the y value for this dot is 2,100. That's an observed value as well. The y value for this dot is 2,300, and that's an observed value too. Well, since I got 6 people in my sample, I got 6 dots here in my scatter plot, and the y value for any of these 6 dots is called an observed value. You can find all the observed values here in this table. For example, if I say that the observed value for this guy is $2,100, all I mean is that the y value for this person is $2,100. And if I say that the observed value for this sample member, I mean the observed value for this person is $2,500, it just means that the Y value for this person is $2,500. Since we have 6 people in our sample, we have 6 observed values here. Now, the symbol we use for an observed value is this. It's pronounced as Y sub I. Please try to memorize that. Now, the Y value for any dot on the regression line is called the predicted value. Okay? For example, the Y value of this dot on the regression line is 2,300. That's the predicted value. The Y value for this dot is 2,500. That's the predicted value too. And the Y value for this one is 2,700. That's called the predicted value. So please remember, the Y value for any sample member is called an observed value, and the Y value for any dot on the regression line is called the predicted value. And the symbol we use for a predicted value is Y hat. Okay? And please remember that the regression equation always shows the predicted value of Y. It doesn't show the observed values. Okay? For example, if x is equal to 11, the predicted value is equal to 100 plus 200 times 11, which is 2,300. You can check it here in the graph. When x is equal to 11, the predicted value is 2,300. You see? Now, if x is equal to, let's say, 12, then the predicted value is equal to 100 plus 200 times 12, which is 2,500. You can check it here in the graph. When x is equal to 12, the predicted value is 2,500. And if x is equal to 13, then the predicted value is 100 plus 200 times 13, which is 2,700. You can check it here in the graph. It's when x is equal to 13, the predicted value is 2,700. So please remember that you can always find the predicted value using the regression equation, and you can always find all the observed values in this table. Now, just to make it easy for yourself, you can think of a predicted value as something like an average for all the observed values when x is equal to a certain value. For example, when x is equal to 11, the observed values are 2,100 and 2,500, and the predicted value is 2,300. Now, if you calculate the average for these two observed values, you're going to get the predicted value. 2,100 plus 2,500 divided by 2 gives me 2,300, which is the predicted value. When x is equal to 12, the observed values are 2,300 and 2,700, and the predicted value is 2,500. Now, if you calculate the average for these two observed values, you're going to get the predicted value. 2,300 plus 2,700 divided by 2 gives me 2,500. And the average for these two dots gives me this dot, which is the predicted value. When x is 13, the predicted value is 2,700, and the observed values are 2,500 plus and 2,900. Now calculate the average for these two dots, and you will get the predicted value. 2,500 plus 2,900 divided by 2 is 2,700. So just to make it easy for yourself, think of it this way. When Excel builds a regression line, it calculates the average for these two dots, then calculates the average for these two dots, and then calculates the average for these two dots, and then builds a line going through the averages for all the observed values. Well, in reality, Excel builds a regression line in a different way. But since we just started learning statistics, it will be easier for us to think of it this way. Again, think of it this way. When building a regression line, Excel calculates the average for all the observed values, and then builds a line going through the averages for all the observed values. Now, since we assume that the regression line goes through the average for all the averages for all the y values, it's very important to understand that the regression equation shows what the y variable is equal to on average when x is equal to a certain value. So the regression equation doesn't show what the y variable is equal to exactly. It shows what the y variable is equal to on average for a certain value of x. So when x is, let's say, is equal to 11, the variable y is equal to $2,300 on average. When x is equal to 12, the y variable is equal to $2,500 on average. When x is equal to 13, the y variable is equal to $2,700 on average. In this context, you can think of it this way. All people who have 11 years of education earn $2,300 on average. When I say all people, I mean just two people who have 11 years of education. And all people who have 12 years of education earn $2,500 on average, right? And for all people who have 13 years of education, the average income is equal to $2,700. Okay? This is how you can interpret the predicted value in context. Now, since the regression equation shows the average values of y for all the values of x, we have to interpret the slope and y-intercept the right way. We know that the slope here is equal to 200. That means each time x increases by 1 unit, y increases by 200 units on average, right? So in this context, you can put it this way. For each additional year of education, people's incomes increase by $200 on average. This is how you can interpret the slope in context. And the y-intercept is equal to 100. That means when x is equal to 0, y is equal to 100 on average. So if I ask you to interpret the y-intercept in context, you can say it this way. For 0 years of education, people's incomes equal $100 on average. Again, if I ask you to interpret the slope in context, say this. For each additional year of education, income increases by $200 on average. Now, if I say interpret the y-intercept in context, just say this. For 0 years of education, income equals $100 on average.
Guys, now it's time for us to learn what a residual is. Now, what's a residual? A residual usually shows how far a certain dot is from the regression line. The symbol we use for a residual is E sub I. Now, in order to calculate the residual for a certain person, you have to subtract the observed value for that person from the predicted value for that person. Here's an example, guys. Let's say I want to calculate the residual for this dot, for this guy. Now, we know that the observed value for this guy is 2,500. Now, the predicted value for this guy is 2,300. Now, 2,500 minus 2,300 gives me plus 200. It means that the residual for this person who has an income of $2,500 and 11 years of education is equal to plus 200. In other words, the distance between this dot and the regression line is equal to 200. Now, the residual for this dot has a positive sign because the dot is above the regression line. Now, let's calculate the residual for this dot. Now, we know that the observed value for this dot is equal to 2,100, and the predicted value is 2,300. Now, 2,100 minus 2,300 gives me minus 200. That means the residual for this person who has an income of $2,100 and 11 years of education is equal to minus 200. That means the distance between this dot and the regression line is equal to 200. Now the residual is negative. Why? Because this dot is below the regression line. All the dots that are below the regression line usually have negative residuals, and all the dots above the regression line have positive residuals. Now let's calculate the residual for this dot, for this guy who has an income of $2,900 and 13 years of education. Now, the observed value for this dot is 2,900. Now, the predicted value for 13 years of education is 2,700. So we have to subtract the observed value from the predicted value. So it's 2,900 minus 2,700 gives me plus 200. That means the residual for that guy is plus 200. The distance between this dot and the regression line is equal to 200. Again, the residual is positive because the dot is above the regression line. So please remember, in order to calculate the residual for a certain dot, you just have to subtract the observed value for that dot from the predicted value. Again, that will show the distance between the dot and the regression line. So basically, A residual shows how far a certain dot is from the regression line. It shows the distance between that dot and the regression line. And if some kind of a dot, if some person, if some kind of a subject has a huge residual, that means that this dot is too far from the regression line. If some kind of a dot has a small residual, that means the dot is very close to the regression line. So please remember that the residual usually shows the distance between a certain dot and the regression line. You can also think of a residual as something like a prediction error. I'll give you an example. Let's say this guy comes up to me and says, well, I have 13 years of education. Please guess my income. Now, I can use the regression equation to guess his income, so I can put in 13 here instead of x. And in that case, the predicted value of y, the predicted value of income, of his income is going to equal 100 plus 200 times 13, which is 2,700. So I can tell this guy, well, if you have 13 years of education, I predict your income to be 2,700. And now the guy says, well, actually, no, you made a mistake when predicting my income. My actual income is equal to $2,500. That means I overestimated, so I overestimated his income by $200. So I made a mistake when trying to predict his income. So think of a residual as something like a prediction error that we make when predicting the variable y based on the variable x. Hey guys, in this video lesson we're going to talk about the correlation coefficient. In statistics, there's a special coefficient that shows how far the dots are from the regression line, and it's called the correlation coefficient. And here's the formula for it. In order to calculate the correlation coefficient, you have to multiply the z-scores of all the x and y values, then sum all the products, and then divide that sum by n minus 1. Well, later on I'm going to show you how to use this formula, but for now, just write this down. A correlation coefficient is always equal to some kind of a number between -1 and +1. Now, if the correlation coefficient is equal to +1, then it means that all the dots are on the regression line, and the regression line is going up this way. In this case, we usually say that there is a perfect positive correlation between the variables x and y. Now, when I say correlation, think of it as something like a relationship. Okay, now if the correlation coefficient is less than +1 but greater than or equal to plus 0.85, then it means that the dots are quite close to the regression line. So some of the dots are on the line and some of them are close to the line, but they're not on the line. In this case, we usually state that there is a strong positive correlation, a strong positive relationship between the variables x and y. Now, if the correlation coefficient is equal to some kind of a number between plus 0.5 and plus 0.85, then it means that the dots are further from the regression line. Some dots are very close to the regression line, but some of them are quite far from the regression line. In this case, we state that there's a mild positive relationship between the variables x and y. Now, if the correlation coefficient is less than 0.5, but greater than or equal to plus 0.1, then it means that the dots are quite far from the regression line. Some of the dots are close to the line, but most of the dots are quite far from the regression line. And that means there's a weak positive correlation between the variables x and y. Now, if the correlation coefficient is less than plus 0.1, but greater than or equal to 0, then it means that the dots are spread across the whole graph. In this case, we state that there's no correlation between the variables x and y. That means there is no relationship between the two variables. There is no dependency between them. The variable y doesn't depend on the variable x. This is how you can think of it. Now, as you can see here, the smaller is the correlation coefficient, the further are the dots from the regression line. The greater is the correlation coefficient, the closer are the dots to the regression line. So as you can see, the correlation coefficient shows how far the dots are from the regression line. Now, or you can put it this way. The closer is the correlation coefficient to +1, the closer are the dots to the regression line. Now, the closer is the correlation coefficient to 0, the further are the dots from the regression line. Now, the same logic applies for the negative values of the correlation coefficient.
Now, if the correlation coefficient is -1, then it means that all the dots are on the line, but the line is going down this way. That means there is a perfect negative relationship between the variables x and y. Now, if the correlation coefficient is between -1 and -0.85, then it means that the dots are very close to the regression line. Some of them are on the line, and some of them are very close to the line. That means there's a strong negative correlation between the two variables. If the correlation coefficient is between -0.85 and -0.5, then it means that the dots are further from the regression line. Some of the dots are close to the line and some of them are far. That means there's a mild negative correlation between the two variables. If the correlation coefficient is between -0.5 and -0.1, the dots are quite far from the regression line. In this case, we state that there's a weak negative correlation between the two variables. And now if the correlation coefficient is between -0.1 and 0, then it means that the dots are quite, I would say, they're spread across the whole graph, and there is no relationship between the two variables. Hey guys, in this video I want to show you how to calculate the correlation coefficient by hand. For that I'm going to use a small example. Let's say I want to build a regression equation that shows the relationship between the number of fish caught and hours spent fishing. So this equation is going to show me how the number of fish caught increases each time when the number of hours spent fishing increases, because we know that the more time you spend fishing, the more fish you're going to catch. So in order to build this regression equation, I surveyed a sample of, let's say, 4 people who just came back from fishing, and I asked each one of them how many hours they spent fishing and how many fish they caught. So the first person says he caught 1 fish and he spent 1 hour fishing. The second guy spent 4 hours fishing and he caught 3 fish. The third guy spent 7 hours fishing, he's got 5 fish, and the last guy spent 8 hours fishing and he's got 7 fish caught. Now, in order to calculate the correlation coefficient, first of all, we have to calculate the average and standard deviation for each variable. So we have to calculate the mean and standard deviation for the variable x and the mean and standard deviation for the variable y. Now, why? Because we have to multiply the z-scores for all the x and y values, then sum the products of those z-scores and then divide that sum by n-1. Now, in order to calculate the z-scores, we have to know the average and standard deviation for each variable. So we're going to start with the variable x. Now, in order to calculate the average for this variable, you just have to sum all the values of this variable and then divide that sum by the total number of people. So it's 1 plus 4 plus 7 plus 8 divided by 4 gives me 5. So I know that the average for all the x values is equal to 5. Now, in order to calculate the standard deviation for this variable, you have to subtract each value from the average, and then square the difference, then sum up all the squared differences and divide that sum by 4 minus 1, then take the square root of the result. So it's 1 minus 5 squared plus 4 minus 5 squared plus 7 minus 5 squared plus 8 minus 5 squared divided by 4 minus 1. Now the square root of that is equal to 3.16, approximately 3.16. Now to calculate the average for the variable y, you have to sum up all the y values. So it's 1 plus 3 plus 5 plus 7 divided by 4. That gives me 4. Now to calculate the standard deviation, you have to subtract each value from 4. 1 minus 4 squared plus 3 minus 4 squared plus 5 minus 4 squared plus 7 minus 4 squared divided by 4 minus 1. The square root of that result is equal to 2.58. Okay. Now here I built a scatter plot that shows the x and y coordinates for all the people in my sample. I got 4 people in my sample, so I got 4 dots here on the scatter plot, and I showed the x and y coordinates for each dot here. Now, the next step is to calculate the z-scores for all the x and y values for each person. We're gonna start with this guy. Okay, he's got x and y coordinates 1 and 1, so the x value for this person is 1, and the y value for this guy is also equal to 1. So we're going to calculate the z-score for his x value first. So the z-score for his x value is 1 minus the average, which is 5, divided by the standard deviation, which is 3.16. So I wrote it down here. 1 minus 5 divided by 3.16 gives me minus 1.27. That means the x value of this guy is 1.27 standard deviations lower
or less than the average. Okay. Now we're going to calculate the z-score for his y value. The y value for this guy is equal to 1, so it's 1 minus 4, which is the average for all the y values, divided by the standard deviation for all the y values, is 2.58. So 1 minus 4 divided by 2.58 gives me minus 1.16. That means the y value of this guy is 1.16 standard deviations less than the average for all the y values. So now we move on and calculate the z-scores for the next guy. It's the x value for this guy is 4, the y value is 3. So we calculate the z-score for his x value. So the z-score for his x value is 4 minus 5, which is the average, divided by the standard deviation for all the x values, which is 3.16. 4 minus 5 divided by 3.16 is equal to approximately minus 0.316. That means the x value of this guy is 0.316 standard deviations less than the average. Now the z-score for his y value is 3 minus 4 divided by 2.58, which gives me minus 0.388. That means the y value of this person is 0.388 standard deviations less than the average for all the y values. Okay. Now the next guy has an x value of 7 and a y value of 5. Let's calculate the z-score of his x value. It's 7 minus the average for all the x values divided by the standard deviation for all the x values. It's 7 minus 5 divided by 3.16 is plus 0.633. Now we calculate the average, the z-score for his y value. The y value for this guy is 5. So 5 minus the average for all the y values, which is 4, divided by the standard deviation for all the y values, which is 2.58. That's equal to plus 0.388. The last person has an x value of 8 and a y value of 7. So it's 8 minus 5 divided by 3.16. That gives me plus 0.95. Now the z-score for his y value is 7 minus 4 divided by 2.58. That's plus 1.103. Now we know all the z-scores for all the x and y values. Now we have to multiply the z-scores of x and y values for each person. So we're going to start with this guy, the first guy. It's minus 1.27 times minus 1.16 is equal to 1.473. Now, minus 0.316 times minus 0.388 is equal to 0.123. 0.633 multiplied by 0.388 is equal to 246. And 0.95 multiplied by 1.103 is equal to 1.1. Now we have to sum all the products of the x and y values. We have to sum all the products of the z-scores. Okay? So it's 1.473 plus 0.123 plus 0.246 plus 1.1 divided by the total number of people minus 1. That gives me plus 0.98. So the correlation coefficient here in this case is equal to plus 0.98, and I calculated it without a statistical software or a calculator. I just calculated it by hand using this formula. So I found the z-scores for all the x and y values, then I multiplied them. Multiplied the z-scores of the x and y values for each person, and then I summed the products of the z-scores, then divided that sum by n minus 1, and I got plus 0.98. That means there's a strong positive correlation between hours spent fishing and the number of fish caught. Okay, now knowing the correlation coefficient, you can calculate, you can build the regression equation by hand. You can find the slope and y-intercept by hand. Now, you can find the slope using this formula. Just multiply the correlation coefficient by the standard deviation of all the y values and divide that by the standard deviation of all the x values. I know that the correlation coefficient is 0.98. Now the standard deviation for all the y values is 2.58. Now the standard deviation for all the x values is 3.16. That's equal to 0.8. I know that b, the slope, is equal to 0.8. Now how am I going to find the y-intercept? To find the y-intercept, I have to keep in mind one very important rule. Please remember that the regression line, in statistics we assume that the regression line goes through a dot with x and y coordinates of x bar and y bar. So this dot on the line has the following coordinates: x bar, y bar. The x value of this dot is equal to the average for all the x values, and the y value of this dot is equal to the average for all the y values. That means when x is equal to 5, y is equal to 4. So you have to put in x bar and y bar here. So you have to put in x bar instead of x and y bar instead of y, and then put in whatever you found here for the slope, which is 0.8, and you will be able to find the y-intercept here. So that means when x is equal to 5, y is equal to 4, we know that the slope is equal to 0.8. That means a, which is the y-intercept, is equal to 4 minus 0.8 times 5, which gives me 0. Now I know that the y-intercept is equal to 0 and the slope is equal to 0.8. So here is my regression equation, and I was able to build it without a calculator and without a statistical software. I can see that the slope is equal to 0.8. That means for each additional hour spent fishing, the number of fish caught increases by 0.8 on average. That means if I fish for 1 more hour, on average, I'm going to be able to catch 0.8 fish. Now the y-intercept is equal to 0. That means for 0 hours spent fishing, the number of fish caught is equal to 0 on average. That means if you don't fish at all, on average, you're going to catch 0 fish, and that makes sense. Now, so I hope you guys now understand how to calculate the correlation coefficient by hand without a calculator. And then please remember that by knowing the correlation coefficient, by finding the correlation coefficient, you can always calculate the slope and y-intercept, and by that you'll be able to build the regression equation by hand.